Okay, so I'm sleepy. So it is fish 2. Yesterday we stopped at Fichie D2 exo 3. Now today I think I should be somehow fast and work through all these exos because there is lots of stuff to study. Okay, so I'm going to start with Fichie D2, but now this time exo 4, right? Now they're saying that given the grammar. Now first of all, what is a grammar? Grammars are just ways of generating languages, and a grammar in THL is very simple. It is just a 4 tuple that is something like x, v, then s and p, where x is the set of terminals. Now terminals are the same as the alphabet symbols. Those A, B's terminals are the same as the alphabet symbols, and V is the set of variables. We're going to see that these variables are the same as the automaton states. We shall see what this means in a minute. And S is called the start variable. This is where we start when we are deriving our language. And then P, these P's are called the production rules. From the start symbol, what can we produce and what can't we produce? We follow these rules. They're called production rules. So a grammar is just a tuple of 4 guys, as you're seeing, and we have types of grammar. We have type 3 grammars. Now we have types of grammars. We have types of grammars, and we have type 3, we have type 2, we have type 1, and we have type 0. Now type 3 is also called a regular grammar because we use type 3 to generate regular languages or type 3 languages. So you can go and see this in cool. I don't have time to explain this because it is making the video long. But type 3 grammars are grammars of this form. We have A. Now when I talk about this, when you see this arrow, I'm talking about the production rules, whereby regular grammars have production rules of this form. We have alpha, B, and we can also say A gives us alpha. And we're going to be saying that A and B, in this case, they belong to the set of variables, this one, whereas alpha belongs to the set of terminals but star. You see? Now the set of terminals star simply means, for example, if our terminals are the same as the boys in the alphabet, you see? And I told you that if I have an alphabet sigma that is having 2 alphabet symbols A and B, then this sigma simply means sigma 0 union sigma 1 union sigma 2 union, it is infinite. So that's why we say the language. Now this language here, which is the same as A, B, star, is this language, and this one simply means the strings in this alphabet that have length 0, and that string is always 1. This epsilon union the strings in this alphabet that have length 1, and that string is A. You get it? That string is A and B. These are sets. Union the strings in this alphabet that have length 2, and of course those are 4. We have AA, we have AB, we have BB, sorry, union the strings. So in this alphabet have length 3, 4, 5, we go on forever. So when a person talks of this A star, the meaning any of these possibilities you are seeing here, I think you get it. So let's see what that grammar looks like. Now when we come to this question here, that is it is x of 4, they're saying given a grammar G, so G is a grammar, and they're like G is equal to, it must be a tuple, so it has this puppy here, A, B, and C. It has this set which is S, A, it has S, and it has P. So this is the X I talked about, this is the V, this is the S, and this is the P. But this is just P, so they must give us the definition for P. You get it? And we can see that they're saying that P, the production rules, they're of this form. We have S goes to A, S, or B, A. Now since this is the rule, and we are seeing capital S, which is now defined because we're saying S equals to this, what about A? So you must also define capital A. And we can see that capital A goes to CA or epsilon. So in this case here, this is the grammar, and for this grammar we are saying the set of symbols of the terminals is ABC. Now this is simply saying this is the alphabet over which this language is going to be defined. Then V is the set of variables, which is S, A. So you have two states in our automaton. Now S, the start symbol, is simply S, and our production rules are these puppies here. So what they're simply asking me is that determine if the words, now we have this one, and this one is equal to, from the question, is equal to A, B, A, C. Now they're asking me to determine if this guy here is in the language that is generated by this grammar. So what I'm going to do is, one, I'm going to say these are my production rules. You get it? These are my production rules. And if these are the production rules, these are the boys I must use to generate my language. So when I see this string here, I'm starting with an A. So I come back, because you must always start from the starting symbol S. So you must always start from here. So we are saying A. So I have to choose. This means a choice. You can either take this or you can take that. So when I see A, this is A, so I'm going to use this rule you are seeing here. So I'm going to come and say, from the start symbol, S can be A, S. But now I need a B. You can see that S can be a BA. You see, S can be a BA because I need a B. So I come and do this. I get my A, but what is S? Now S is BA. So I have B, A. You see, now I need an A. But the problem is, now I have A here because we can, these guys are called terminals because terminals means the end. Whenever I have these small letters, you can't replace them. Whenever they appear, they will never be rejected. They will never be replaced by anything. So this capital A is called a variable, so you can replace it. But from here, you can see that A can only give us CA or epsilon, which means there's no way I can get a small a from capital A from these rules. So I can simply say this string you are seeing here is not in the language because we have hit a dead end. We're having capital A, but we cannot get a small a from capital A from the rules. So this string you're seeing here is not in the language that is generated by this grammar. I think it makes sense. Now this was part 1. Now part 2, they're saying the string is A, B, C, C, C. Now when you see this, we need an A at first. So I'm going to use this first production rule. So I'm going to be like S gives us A, S. Then I need a second A. How can I get A from capital S? I'm going to say S equals AS again. So this one is going to become A, but now S is A, S. Now I need a B. because now I need a B here. So how can I get a B from S? I come and take this boy here. So this is the same as A, B, A. You get it? And now from there, we have capital A, but what we need C's. So we see A can give us a small c. So I come and say this is A, B, but now A is going to become C, A, that is cool. And I need another C, but since I have capital A, which is the variable, capital A can be replaced, it can give me C again. So this is A, B, C. Now A has become C, A. I think it makes sense. Now since I want another C, I have capital A, I can get CA from capital A. So this is A, B, C, C. Now C is going to become C, A. Now finally, they're saying capital A can give me epsilon. So I have A, B, C, 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 epsilon. But now this is the same as saying it is just A, B, C, C, C. So this string here is in the language because we can use this grammar, these production rules to generate it. So this one is in the language. Good. Now another string they're talking about is W3, and they're saying this one is C, A, B, B, A, C. Now they want us to determine if this string is in the language, but from these were our production rules. The production rules were S goes to A, S, O, it goes to B, A, and A could go to C, A, then epsilon. So when you see, we must always start from the starting symbol. But when you see the starting symbol, we have two choices. We can either start with AS or BA, which means there is no way we can start with a small c. No way. Small c happens after we have seen a B, which means this string you're seeing here cannot be in the language because from the starting symbol, there is no way you can get a small c. So this one is not in the language. The only way you can get a small c is in A, and A is not is in the A cannot be produced. A only comes after you have seen the first state, the first variable, the initial variable is this one. It says all strings in this language can either begin with a small a or a small b. So this one is not in the language. That is simply that. Then you have another string is this one, and that string is given by AB. So they want me to determine if AB is in the string. And how can I do that? Since I need an A, I come and say from the production rules, S can give me a S. Now I need a B. How can I get a B from S? I take BA. So this one is now A, B, A. But they're saying A can give me epsilon. So this is A, B, epsilon, which is simply A, B. So this string you are seeing here is in the language because we can use these production rules to generate it. Simple. Now, the next, that is part 2, they're saying trouver le langage généré par G. And when I have a grammar G, now the language that this grammar generates is the same as saying L, G. This means the language that is generated by this grammar. Now, what is interesting here is one, we have what we call the automaton. And the automaton is that device that accepts regular languages. Now, to draw the automaton, we're going to do this. From this grammar, we see we have capital S, we have capital A. Because from the set, from here, we saw something interesting. We saw that the set of variables is SA. And this set of variables, now these are simply the states in the automaton. So what I'm talking about is this. So our automaton is going to have two states. It's going to have S, and it's going to have A. You get it? Now what I'm doing is one, they ask me to find the language that this grammar generates, but for me to do this, I need to find the automaton, because for the automaton, I can simply reason it out. Now since here, this is the start symbol, we put this symbol here to mean it is the starting symbol. You can go and read Q5. Now, from here, we see that in this grammar, when I see A, I come to S. So I do this. That is a loop. When I'm in S and I see A, I come back to S from this grammar, from these rules. And when I'm in A and I see a B, I go to A. When I'm in S and I see a B, I go to A. But since you see from these rules here, since A produces epsilon, so you can say A is an accepting state. You can go and read the code to understand what I'm doing. So accepting states always have two circles, and initial states always have this arrow to mean that they are initial. You see? Now from this grammar, I see that when I'm in capital A and I get a C, I come back to capital A. You get it now. This epsilon simply means that A is accepting. So we have this automaton, and when you see this automaton, it says any number of A's, then a B, then any number of C's. That is the same as saying it is A star, you see? Then we get a B, then we get C star. Have you seen? This star simply means any number of A's, and this star means any number of C's. Not the same number of A's and C's. No, there can be different number of A's and different number of C's, but we're having one B in the language. So we can simply see that this language is the language A, M, B, C, N, such that M and N can be 0. So this is the language. But for me to do this language, what I do, I use these production rules to draw the automaton, and from the automaton, I can simply see that we can take any number of A's. That's why I say A star, then one B, then any number of C's. That's why I say C star. Now we can have a 0 number of A's and 0 number of C's, whereby when we see B, it is accepted. Simply because from this language here, we can see that when I start from the start symbol S can give me BA. But what is A? A can give me this, or A can give me epsilon, so it means B. So it means S can give me B, so B must be in the language. And you can see when I get a B, I go to accepting state. In a number of A's, one B, in a number of C's. So this is the language that this grammar here is generating. Now this was exo 4. I think you understand it now.